Polynomials, we have two definitions for polynomials. The first one is a polynomial you can't divide by a variable or take a square root of a variable. If you divide by a variable or have a square root, then it is not a polynomial. For the degree of a polynomial, degree is the highest exponent or exponent total of a term. If you have a single variable, we'll take the highest exponent. If we have more than one variable, we'll take the exponent total, or the sum of the exponents of each term, and the highest exponent total will be the degree. Title of the first section is Degree of a Polynomial. First polynomial we'll look at is 3x squared plus 2x minus 1. Again, the degree of the polynomial is the highest exponent. Highest exponent in this case would be 2, so the degree would be 2. Second question, x cubed times y squared plus x divided by 2 minus y. Looking for the degree again. When you have two variables, we can add the exponents together, which would make this an exponent total of 5. The other two terms have an exponent of 1, so the degree for this polynomial would be the exponent total would be 5. And last question for the section, x squared minus 1 over x. Looking at the highest exponent would be 2, but the second term we're dividing by x or dividing by a variable. Anytime you divide by a variable, this expression is not a polynomial. If it is not a polynomial, then there is no degree. The expression is not a polynomial. Title of the next section is Simplifying Polynomials. In this section, we'll simplify polynomials by combining like terms. First problem. First set of parentheses is 3x squared minus x plus 2 plus a second parentheses x squared plus 4x minus 9. To simplify polynomials, we can combine like terms. Like terms would be the same variable and same exponent. Combining the x squareds together, we'll have 3x squared plus another x squared, which would be 4x squared. Combining the x's, negative x plus 4x would be plus 3x. Negative 1 plus 4 would be 3. And 2 plus a negative 9, or 2 minus 9, would be negative 7. So our final answer, 4x squared plus 3x minus 7. Second question and last question for the section. First parentheses, 10x squared minus 3xy plus 4y squared minus a second parentheses 3x squared plus 5xy. Simplifying polynomials, we can subtract these two terms together. Again, combining like terms. The x squared we can combine with the other x squared. 10x squared minus 3x squared would be 7x squared. The xy we can combine with the other xy. Negative 3xy minus a positive 5xy will be negative 3 minus 5, which would be negative 8xy. And last term we haven't used 4y squared. There's no other 4y squareds to combine with it, so it will stay the same, plus 4y squared. So our final answer is 7x squared minus 8xy plus 4y squared. Title of the last section today is More Simplifying Polynomials. First question is 4a times, in parentheses, 3a squared plus b. Simplifying this expression, the 4a, we can use distributive property to multiply inside the parentheses. Multiplying 4a times 3a squared, the coefficients we can multiply. 4 times 3 would be 12. And a times a squared, if you want to, you can put a 1 for the exponent. Multiplying like terms, we'll add the exponents. So a times a squared would be a to the third. Plus 4a times b. Since they're different letters or different variables, you can write them side by side, which would be 4ab. So your final answer, 12a cubed plus 4ab. Second question, inside parentheses x minus 3y to the second power. Simplifying this expression, since we have two terms on the inside separated by a plus or minus sign, the squared means we'll have the same parentheses twice. So x minus 3y times x minus 3y. We have two parentheses or two binomials being multiplied. To simplify this, we can multiply using FOIL. Multiplying the first terms, x times x would be x squared. Multiplying the last terms, x times a minus 3y would be minus 3. X times y would be xy. Multiplying the inside terms, negative 3y times x would be negative 3. And we can put x first times y. And multiplying the last two terms, negative 3 times negative 3 would be positive 9. And y times y would be y squared. Simplifying, we can combine like terms. Minus 3xy minus another 3xy. Negative 3 minus 3 would be negative 6. And the xy would stay the same. Plus 9y squared. So our final answer, x squared minus 6xy plus 9y squared. And the last question for the section. The first parentheses, x squared plus xy plus y squared times a second parentheses x minus y. Multiplying, we have a trinomial with 3 terms times a binomial with 2 terms. Similar to distributive property, we can multiply x times each of the 3 terms inside the parentheses. And after that, we can multiply y times each of the 3 terms. Multiplying x times x squared. Again, you can put an exponent of 1. Multiplying like bases, we'll add the exponents, which would be x to the third power. X times xy. Multiplying 2 x's will be x squared. And putting y after, so x times xy would be x squared y. And multiplying x times y squared would be x y squared. For the second part, we'll multiply negative y times each of the three terms. Negative y times x squared would be minus x squared y. Multiply negative y times xy. We'll have negative x, and y times y will be y squared. And multiplying a negative y times a y squared, we'll have negative y to the third power. Combining like terms, x squared y minus x squared y. Each of these would cancel. And also xy squared minus xy squared. Each of those would cancel. So our two terms left is x cubed minus y cubed. So our final answer would be x cubed minus y cubed.